A cave diver enters a long underwater tunnel. When her displacement with respect to the entry point is 20 meters, she accidentally drops her camera. But she doesn't notice it missing until she is some 6 meters farther into the tunnel. She swims back 10 meters but cannot find the camera, so she decides to end the dive. How far from the entry point is she? Taking the positive direction out of the tunnel, what is her displacement vector relative to the entry point? So, this is my drawing in the problem. So, this is my drawing in the problem. In the given problem, the diver's displacement with respect to the entry point is 20 meters. So this is where the diver is located. And then she swims farther ahead 6 meters. So from this point to this point, that is 6 meters. And then she swims back 10 meters to find her camera. So from this point to this point. So the problem is how far is she from the entry point? So analyzing that statement, so from this point to this point is what we are looking for. What is her distance from this point to this point? So that's why I put question mark, since this is what we are looking for. So to solve this, we have to now identified the given 20 meter, 6 meter, and 10 meter. So we have to write what is required. So the required in this problem is how far from the entry point is she, and letter B is what is her displacement vector relative to the entry point. So first we have to solve letter A, how far from the entry point is she. To solve this, we just have to add 20 meter and 6 meter. So 20 meter plus 6 meter is equals to 26 meter. And then based on this answer, we have to subtract 26 meter by 10 meter. So 26 meter minus 10 meter is equals to 16 meter. So that is the distance of the diver to the entry point. So this distance is now 16 meters. So letter B, what is her displacement vector relative to the entry point? So to solve this, we have to set the direction out of the tunnel as the direction of the vector. So direction out of the tunnel is equals to positive unit vector, and direction into the tunnel is equals to negative unit vector. So in the given problem, it is said that taking the positive direction out of the tunnel. So that is why we set the direction of the tunnel as positive unit vector, since it is in the problem. So now to solve this, we have to multiply it by its respective unit vector. So 20 meter is multiplied to negative unit vector, since 20 meter, the arrow of the 20 meter is to the left or into the tunnel. So that's why we have to multiply it by negative unit vector, and its answer is negative 20 meter unit vector. And then 6 meter is also multiplied by negative unit vector, so is equals to negative 6 meter unit vector. And then 10 meter is multiplied by positive unit vector, since 10 meter, since the arrow formed from this point to this point is to the out of the tunnel. So that's why it is multiplied by positive unit vector, and its answer is 10 meter unit vector. And then to solve the displacement vector relative to the entry point, we have to use this formula. And then after that, we just have to substitute the given. So negative 20 meter unit vector plus negative 6 meter unit vector plus 10 meter unit vector is equals to negative 16 meter unit vector. So that is the answer.